Hi there, this is Jiayuan from Shanghai Jiao University. I'm going to introduce here with our work MatchTime, which is about automatic soccer game commentary generation. This work is cooperated with Haoning, Chang, Yanfeng, Wang, and Weidi. We are all from Shanghai Jiao University. We will go through our presentation with these parts: motivation, the dataset, MatchTime, and our commentary generation model, and finally the experiment and results. First of all, let's introduce what is soccer game commentary generation. Let's take a look at some demo videos of what we've done in this task. On the left side is a video clip showing some events happened during the soccer games. And as on the right side, we will give some corresponding commentaries via our commentary model. Such model is available to tell what is happening on the court and give several examples of different types of incidents. The model should be able to automatically see and make accurate commentaries. As now is an example of a free kick, the model would recognize the free kick and knows its result of being cleared. And as well as other examples such as injury on the court, which should be available to be seen and to be accurately commented as well. After seeing some examples, here is a question on what do we need to make good soccer game commentary generation. Along with the source of machine learning, we should have a dataset which is large-scale and well-prepared for the soccer games especially, containing dense captions and commentaries. Also, to caption the video, we have to train a visual language captioning model to doing captioning tasks. So far, there is a existing dataset called SoccerNet Caption, which covers over 400 untrained soccer full game videos, and with over 78 commentaries per game with second level timestamp, and each commentary would have an average length of over 21 words. Also, it provides an anonymized version eliminating the bias of different players and teams. Although we already have a large-scale multimodal dataset for soccer commentary, there are still bunches of challenges left for us to solve. First is about data. In the current soccer caption datasets, the quality of timestamps is not satisfactory, and we cannot fully utilize the available data sources, such as the audio check. And for example, with part of them could connect well with the contents in the video, much more commentaries are not aligned with the videos. There are more or less a bias between them. And even some commentaries is not visually evidential in the videos. Such misalignment are in great portions, and there are only 26% of commentaries are temporarily localized within 5 seconds to the ground truth. Also, for our model, the current work cannot train it from a model with language inferenceability. And finally, as for the evaluation was weak due to they are all towards all domain and not especially for soccer. According to those challenges, we contribute a dataset, SoccerNet Caption Test Align, which is a dataset manually annotated with soccer commentaries and timestamps in the dataset. Such a dataset is used as a test set and a new benchmark for soccer game commentary generation tasks. And also the dataset MatchTime, which is temporarily aligned with timestamps for all the commentaries in the dataset. And then for the architecture of our model, we propose the model Match Voice, which is a Q-format-based vision language model utilizing the inference ability of LLMs. And finally, we designed the GPT score to evaluate our automatic commentaries with the inference of LLMs as well. And here we will go more detailed about our MatchTime dataset. We divide the alignment pipeline into 2 steps to construct our dataset. First of all, we deal it with a coarse alignment, that we recognize the audio check and get the background narration text of the soccer broadcast. And then we use Llama 3 to summarize into integrated events descriptions of equal time steps. And finally, we still use Llama 3 to estimate timestamp considering the original commentary and using the summarized event descriptions. And after we have done the course alignment, we continue to perform fine-grained alignment. We first manually annotated the timestamps of all the commentaries in 49 soccer games, which makes our dataset soccer net caption test align. And with the timestamps from the course alignment as base, we continue to doing some contrast learning to match the commentary text with its proper image frame. And using such pipeline, we processed all the timestamps in the rest of the soccer net caption dataset, and finally we derived our own dataset MatchTime. As for the commentary generation model, we basically propose a prompt tuning model to link visual and textual stuffs. In our match voice model, we encode the frames with temporal information and aggregate them to be projected to language prompt embeddings. Such aggregation is a Q-format-based structure and is the only trainable part in our entire model. Then we use large language model to doing some inference of the commentary sentences to generate the final commentaries. And to summarize it, we just first use frame-wise encoding with temporal embeddings and across a Q-format-based aggregator, and then to put them into LLM decoders to finally generate our model. Here are some experiments and results in our work. As for the alignment, some applications is showing that each step from coarse alignment to fine-grained alignment is reasonable, and each step we have some progress to make a more accurate dataset of timestamps. And finally, after the pre-processing, which is also coarse alignment, and the contrastive align, which is also fine-grained alignment, we finally get our dataset of MatchTime to put them into the next stage training tasks. Also, the right side is the commentary results, quantitative results, that is showing the accuracy of timestamps can directly influence the results of commentary. And our match voice reaches the state of the art in all the metrics of soccer game commentary generation. Also, we've done some fine-tuning on the large language model, which is actually Llama 3 8B version. And we apply LoRa to the LM decoder in the match voice. And of course, some fine-tuning on decoder can continue improving our commentary generation. And finally, we're showing some qualitative results, which is about commentary generation. And it shows, according to these 4 examples, just separately showing our advantages in richer semantic descriptions and full commentaries of multiple incidents, and the accuracy of descriptions. And finally, the picture D is showing our ability on prediction of incoming event. And also, as for our course to fine alignment pipeline, making our MatchTime dataset is showing the ability of aligning the timestamps from biased to accurate ones. Okay, so that's all the work in our project MatchTime. If you're interested in our work, just feel free to contact me via email. And basically, we are strongly interested in video understanding and sport analysis. And to make a review, our future work around the soccer commentary generation is coming soon. And it is about a bigger data set and a better visual encoder. And as the following is our QR codes of codes, paper, website, and our official WeChat media. And welcome to scan and contact us. Okay, so that's all for our presentation. Thank you for listening. Thank you.